Hello, welcome to another episode of James Chris Science Videos. Today we are looking at conservation of mass 2. It's useful if you watch the conservation of mass video first, conservation of mass 1 first, because that gives you an idea of how on each side of the equation, the reactants and products, the mass of both have to be the same, either side of the arrow. So what I'm going to do is I'm going to show you another video today just to see if I can challenge that and get you to think about what's happening. So for this experiment, what I've got here is I've got a flat bottom flask that I'm going to put onto here, and I'm going to add onto that, I'm going to add some, what have I got today? Sulfuric acid? No, hydrochloric acid we found in the cupboard. Now, I'm not going to worry about exact amounts because it's not that precise an experiment. And that gives me a reading of 325.06. So I'm going to write that down on a piece of paper. So I've got it here to the side. 325.0, it's gone down to 0.4. So into that, I'm going to add some marble chips. So calcium carbonate. When this goes in, see if you can see, oops, it helps to actually get them into the beaker. And I'm going to put quite a bit in. So my first question is there a reaction going on? How can you tell? So if you look inside, is there a reaction going on? And the answer you should come up with is yes. How do you know a reaction is taking place? Because it's bubbling. It's effervescing. You can see the gas coming off here. So the reaction is taking place. The gas that we're going to get, well, the clues in the word, this being calcium carbonate, what gas might be coming off calcium carbonate, well, the clues in the word, the gas that's coming off is carbon dioxide. So if you come round here, I don't know whether you can see this, over here. It doesn't happen all that quickly, but we've got here a reading of 328.74, and you can see it's gone down to 7.3. Now if I wait, about every 20 seconds, it goes down 1, and it goes down again. It'll go down to 7.1 in a second. Now, last lesson I showed you a reaction where it gained mass. In this one, it's losing mass. And I want you to think about that for a second. Why is that appearing to lose mass when conservation of mass says that the mass must be the same with the reactants and the products? And so this doesn't seem to follow it. So hopefully you've thought about that for a couple of seconds. And what I'm going to do now is I'm going to do this. I'm going to put a balloon over the top like this. Now, last time I did this, I managed to spill it everywhere. It's a bit fiddly. Ooh, nearly. There we go. Right, now. Okay, what you can see now happening is that the balloon is beginning to fill up. So the gas it's producing is now stuck in the system. But because of that, the mass will now, once this is up, stay constant, because nothing is now leaving the system. So that's quite cool, isn't it? I quite like that. So eventually, if the pressure is good enough, that will stay. And the mass should now stay constant. You can see it's not moving at all now. So it's staying the same. So what does that mean? Well, let's go back to the board and have a look at the board. And we'll try and explain it. So let's put this onto here. So in today's reaction we had, I'm going to call it calcium carbonate. Carbon-8 plus we had hydrochloric acid. Excellent, a bit of rocky as we go into this. Perfect timing. So calcium carbonate plus hydrochloric acid is going to give me 3 products. I'm going to get water, I'm going to get calcium sulfate. Now you don't need to know yet how we got to that. Chloride, because it's not sulfuric acid. And we're going to get carbon dioxide. So with that, I've got a solid, a liquid, a solid, and a gas. And the gas is going to go into the atmosphere. Now, I'm going to make up some random figures because it doesn't really matter at this point. Let's say I had 12 grams of calcium carbonate and I had 8 grams of hydrochloric acid. And it turned out I had 10 grams of water, 6 grams of calcium chloride. Then how much would my carbon dioxide weigh? Bearing in mind the mass of this side has to equal the mass of this side. So here I've got 12 plus 8, which equals 20. I've got 10 plus 6 plus something that needs to equal 20. So 10 plus 6 plus 4 is going to make that side the same as that side. So it appears, because I've got water and calcium carbonate into my beaker, it appears that what I've got, and it appears that I've lost 4 grams because that carbon dioxide has disappeared into the air. But in fact, what I've got is I've got the same amounts on both sides. So what to do with this? Well, my first lesson we did magnesium plus oxygen. So if I'm reacting something with a gas, it's going to appear to gain mass because I'm adding something from the air. If I make something that produces a gas, it's going to appear to lose mass because that gas is going to go off into the air. And so that is something that you need to kind of think about. What I want you to do, I want you to see if you can measure. Now, I've deliberately used fudge numbers so that you haven't got kind of accurate numbers to use. Oh, that's the balloon gone. What I want you to do, and this might not work, I don't know how accurate your parents' equipment and stuff in the kitchen are, but I'd like you to do an experiment at home to see if you can work out how much carbon dioxide is released. So for this, what I'd like you to do is to get an amount of baking soda. Might be called sodium bicarbonate. Your parents hopefully have got some somewhere in the cupboard. And you're going to need some vinegar, which is an acid. It's a very similar reaction to this. It's going to make carbon dioxide. Now, I'm hoping that your parents have a scales in the kitchen that's reasonably accurate. It doesn't need to be massively accurate, hopefully to the nearest gram. So what you do is you're going to put a mug onto the kitchen scales. Into that mug, so you're going to weigh that and you're going to measure the mass of the mug. You're then going to pour in the vinegar. So into there goes vinegar. And you are then going to work out the mass of the vinegar. So let's say the mug is 50 grams, and you put the vinegar in, it says 52 grams, and the vinegar would weigh 2 grams, for example. You're going to find out the mass of the vinegar. You're going to take that off and put it to the side, and I want you to weigh an amount of baking soda. Baking soda. So I would suggest probably 4 good teaspoons. See how much that weighs. Once that's done, you're going to put the mug with the vinegar back onto the scales. I would make sure that you've got a big mug, by the way, because it does fizz up and go everywhere otherwise. You put in your baking soda, and then you watch, and you have to wait until the reaction's finished. So it's going to bubble and go everywhere. Once it's finished bubbling, I want you to take the reading, and however much that reading has gone down is how much carbon dioxide was produced. And I want you to see if you can come up with a reading for how much carbon dioxide there is. Then once you've done that, could you write that up as a small experiment. I would like your method, what you did with a diagram. I would like some results of how you can do that how you want. And then I want a conclusion, which should be how much carbon dioxide you managed to produce. If you could do that and then send that to me, that would be wonderful. Thank you very much. Final word of the day is the.